Welcome, welcome everyone. So today we will hear from Christopher Stevens, who is a geocryologist with 18 years of experience working on Arctic and subarctic projects. And he specializes in permafrost and soil geotechnics, periglacial geomorphology, ground thermal analysis, and numerical thermal modeling, as well as thermal design of infrastructure and the development of permafrost mitigation measures to improve ground stability. And he has worked widely on both terrestrial and subsea permafrost related to mining, transportation, and oil and gas projects in Alaska, Canada, Russia, and Greenland. And he has contributed to thermal designs and construction of critical infrastructure, including frozen core, frozen foundation dams, among others. And he's also the owner of Northern Permafrost Consulting, which is a consultancy focused on providing practical solutions to solve present-day and future permafrost challenges. And he is working out of Eagle River, just north of Anchorage in Alaska. So Christopher, grab the screen and share.
Great. Thanks, Anna. Thanks for the introduction, and let me share my screen here. Are you able to see the presentation slide? Great. Great, thanks. Thanks everybody for joining the call. As Anna mentioned, I'm going to give a pretty short presentation, about 30 minutes. And I'm going to talk about building a framework to understand permafrost at local and regional scales. I thought the topic was fitting, given that the Permafrost Discovery Gateway, my understanding is that it really has an opportunity to bring together information and build an understanding of permafrost at different scales, whether we're talking about a community or something more regional. Today's talk is going to kind of have a viewpoint and a focus on infrastructure and its interaction with permafrost, but clearly for some time now, permafrost scientists have been using a similar type approach where we bring together information, build an understanding about permafrost that becomes useful to end users beyond just the science itself. Okay, so today's talk, I'm going to start off by just pretty high level, talking about permafrost and infrastructure for those that are less familiar with this topic. And then I'll quickly go into what is a permafrost framework and its importance for infrastructure design, mitigation, and adaptation to climate change. And those are kind of the three categories that people are talking about these days: is design, obviously, of infrastructure, mitigation measures that might be needed when we do see impacts to adverse impacts to the infrastructure, and then long-term thinking, how do we adapt the existing infrastructure, or how do we build new infrastructure that addresses climate change? I'm going to use an example of a study, a larger multi-year study that was completed in the Great Slave Lowlands of the Northwest Territories, Yellowknife, Canada, as an example, a really good example, in my opinion, of how a framework of permafrost was developed, and we'll get into that towards the latter part of the presentation. So for some time now, we've been saying that permafrost is changing, and there's climate-driven changes to permafrost. There's some good scientific research out there that's been conducted over decades now to say that permafrost is changing. It's changing a little in different ways. It's having impact on different parts of the environment, but it's also impacting infrastructure clearly. So these changes have been occurring for some time now. This isn't anything new. And the other part that I wanted to highlight in the context of infrastructure is that it's not only permafrost thaw, the change in state from frozen to unfrozen material, but it's also the period of warming and the change in geotechnical properties of the soils, perhaps, or even bedrock during those warming periods that can impact infrastructure. Why do we care? Well, we care for a lot of reasons, but some of the broader topics here is that these changes are having social, economic, and environmental consequences. And there needs to be some actions, and there are actions in place to try to address this. I thought too I would highlight that millions of dollars to address some of these challenges used to be thrown around. Now we're in the hundreds to billions of dollars of estimates for addressing challenges with infrastructure. It of course depends. Are you talking about a highway section that's 300 meters long, or are you talking about a whole region that has infrastructure that needs to be addressed? Let's see if I can. Yeah. Some of the infrastructure challenges that we're having, unfortunately, they're now pretty common. It's not an anomaly, but we're seeing impacts that are more widespread, and the rates of change in they kind of correlate with rates of change in permafrost as well. There's a lot of reasons, and sometimes those impacts are pretty site specific to the piece of infrastructure, but then there's also kind of a more broad categories that explain why there's some impacts to this infrastructure. Some of the common reasons, unfortunately, are inadequate design in some cases, or selection and implementation of construction methods. We also have cases where owners and operators of assets are not conducting really well maintenance procedures on the pieces of infrastructure, and so that has an impact. And then other cases, climate change is driving the system, and we're seeing conditions that exceed really the design criteria for the piece of infrastructure, or the piece of infrastructure is aging and it's well beyond its service life. So a whole bunch of reasons. I did want us to say as well that some of the infrastructure impacts, they're irrespective of climate change. So inadequate design and construction, it can be irrespective of climate changes. Those impacts are, reasons hopefully we can address on projects and have less occurrence of those types. The images I have at the bottom of this screen are showing 3 different examples of infrastructure that's being impacted by permafrost. We move from left to right. The left image is a highway embankment where there's perpetual thaw of ice-rich permafrost in the foundation and failure of the embankment. We have other cases where I've worked on highways where there's sinkholes developing. There's thermal karst in the foundation that's developed as a result of thermal erosion and water transporting heat to melt that ground ice. And those are another example of highways being impacted by permafrost. Some of this infrastructure is not private, it's open to the public, and so permafrost can result in a pretty significant hazard that a lot of the users of the infrastructure are not familiar with. They're not trained on identifying these hazards. So this example of a road, this is a public road that can be accessed by anyone that may not be aware of these types of road hazards. The image in the middle of the screen is showing you a pipeline rack, a series of pipelines that are elevated by these 2 vertical pipes, these adfreeze pipes. And obviously there's something going on. There's differential settlement of the adfreeze piles. The pile itself gains its strength and its bearing capacity of the load above it from the freezing of the ground around that pipe. And so this is an example of where I was talking about the warming effects are also important. It's not just thaw of permafrost, but the warming of it as well. As we warm the ground, the properties, and in this case, the adfreeze strength around a section of that pipe can change, and in the context of ice-rich material can lead to increased rates of creep of the pile. The last example on the far right is showing you, and hopefully you can see the animation, but it's a time series of synthetic aperture radar images, or SAR images, that were piled on top of each other over time, over a number of years. And it's of a site, it's not in North America, but it's another location. It's a gold mine where it's open pit mining. And what you're seeing here, this lobe that's moving down slope, it's actually displacement of a waste rock pile or waste rock storage area. So as the material is mined, portion of it that doesn't have economic value for processing of ore gets stacked or piled up onto the surface of the land here. And unfortunately, this site has really warm, ice-rich permafrost, and so this whole mass of waste rock is, over time, it's been displacing downslope, and there's creep in soil creep in the foundation as well. Further down a slope, you can see that, hopefully you can tell, perhaps you can't, but there's a number of buildings and infrastructure that's actually being overridden now by this moving mass of rock and then overburdened soils. And then further down slope, there's a river. So it potentially has environmental consequences as well. So it's just a little bit of background information on permafrost and infrastructure for those that are a little bit less familiar about the topic. But today I wanted to kind of frame that and those challenges within what I'm calling a framework for permafrost, or a permafrost framework, which in my opinion is really important to develop. And like I said early on in the presentation, I think the Permafrost Discovery Gateway has an opportunity to pull together information and develop knowledge that can really help those of us working on the infrastructure side of this topic to make more informed decisions. And perhaps, projects should be moving towards developing more of these frameworks. So what is a permafrost framework? What I'm saying here is that it's simply a collection of information that can be used to understand past, present, and future permafrost conditions of a site or a region. And there's three parts to that that are really important. It's not only characterizing and understanding what's there today. There's a lot of value in understanding what the past was, the geologic past, the conditions under which materials were deposited, so superficial geology, the aggregation or the formation of permafrost, and or associated ground ice that forms. So it's past, present, and then of course we want to know something about the future, especially when we talk about climate-driven changes to permafrost. This information can be widespread, and I'll kind of go through a few examples of what kind of information is brought into developing a permafrost framework. But it's a lot of different information that usually is analyzed by a subject matter expert or a series of subject matter experts that form a team that can then convert that information into useful knowledge. As I said here, really the key to developing the framework completely is to move from that information to knowledge, and then the end goal of where we want to get to is having a resource there to make informed decisions. So why is it needed in the context of infrastructure? Well, unfortunately, permafrost isn't the same everywhere. If permafrost physical and thermal properties were similar or the same throughout the landscape, it would be a lot easier to design infrastructure to accommodate some of the challenges, perhaps. But we know it's spatially and temporally variable, and its response to climate change and also the thermal forcing from that infrastructure is variable across the landscape. It varies with space and time. So we're really, when you talk about designing of infrastructure, it has to address the heterogeneity of permafrost that varies across space, and it also has to look at the time factor to that. Or we have to be designing infrastructure that we're willing to accept that we're going to maintain it and accommodate some of the physical changes, for example, that may result. We also need to know and have a comprehensive understanding of permafrost. We want to talk about mitigation measures. How do we address areas that are being impacted currently by permafrost and are showing impacts? If we want to talk about future adaptation of infrastructure, we also need to know more than we might just achieve by drilling a handful of drill holes, for example, at a site. There needs to be a wider understanding, and that's what I'm trying to, I guess, communicate today. So what can a permafrost framework look like? This is something that is done more routinely, I would say, in a lot of scientific programs, and less so on projects. It's not to say it's never done on an industry project, but it's a little bit less common where we get this comprehensive understanding of permafrost at this level. The framework would kind of consist, and this is just an example graphic showing you an example, but you bring in data. It could be historic, it could be recent information that's collected. You have climate and climate change outputs, traditional knowledge, right, of a region that has very high value to understanding permafrost and changes on the landscape. You have terrain and vegetation, superficial geology maps, ground ice, soil geotechnical, both borehole logs and analysis of the material in the lab, ground temperatures and understandings of hydrology, surface water and groundwater systems in the area. So when we talk about this information, it's not really straightforward sometimes to obtain. Superficial geology would be an example of, in a lot of areas, there's not detailed superficial geology maps showing what's potentially there, and so it's a big challenge, and it's a piece of information that needs to be generated for projects. All of this information and more can go into different levels of analyses that are driven by the scope of the project and really the direction of information that we need to understand about permafrost. It can also identify data gaps where we want to put more resource towards investigating in the field. And then there's a number of outputs, and I just kind of threw these three examples together. Under example outputs, we might have analysis that results in predictive permafrost maps that show spatial variability, estimates of permafrost temperature and how it varies across the landscape. Could be active layer depth or that seasonally thawed zone. How deep is it in different areas? Where does permafrost occur and where it's absent? We could also have permafrost degradation maps and models for a region or for a site, and then also products that are derivatives from the analysis that show thaw sensitivity of different areas, let's say at a community scale or even across a region where we might have a piece of linear infrastructure. So a lot of different outputs, but usually it takes multiple types or pieces of information that are analyzed together. And all of this starts to build that framework and an understanding of permafrost that can be used in the context of infrastructure for these different categories here. Design, how do we design to address what's actually there and how it varies and how it might change in the future. Construction and maintenance, it can be really informed by some of these products. Mitigation of permafrost, and of course, risk assessment and decision making. These are just a couple examples. But you can see, just even from risk assessment, the topic there. Now, how would you be expected to complete a reasonably complete a risk assessment if you didn't have this knowledge base about permafrost? Even a qualitative risk assessment really should be informed by this level of work, in my opinion. And then, of course, there's a lot of end users and stakeholders that need to be making decisions as well on projects, and they need to be informed to the rest of what the knowledge is at the time. So I'm going to spend the rest of the presentation talking a little bit about a case study, an example of where a framework for permafrost was developed. This is a study led by the Geologic Survey of Canada, with various partners. I've just named a few here: the Canada Centre for Remote Sensing and Government Northwest Territories, among others. But this is a study that was completed and had a focus on understanding permafrost and building this framework in the lens of advancing and better addressing permafrost impacts to transportation infrastructure, in particular highways. It was conducted in the Great Slave Lowlands, so the Northwest Territories of Canada. Here you have a number of different types of highway infrastructure moving from left to right in these images that are shown on the screen. There's seasonal roads, not only ice roads that transverse across lakes and ponds, but also have overland portages And a number of individuals at the Geologic Survey Canada have been working or have worked on the seasonal ice road route that services resource development projects, in particular mining projects in the Canadian Arctic. We also, around Yellowknife, have a all-season or all-weather road, Northwest Territories Highway 3, that goes along the Great Slave Lowlands and is really the only route into Yellowknife. So it's a very important public transportation route and also a resupply route. We'll talk about that highway as well. And then I just wanted to put a picture on here from the area where this is abandoned. The third picture on the far right is an abandoned section of highway where there's no longer maintenance, and you can see the differential thaw settlement of the embankment when you aren't maintaining a road that transverses across very ice-rich permafrost. So we'll focus on Northwest Territories Highway 3 into Yellowknife. It between 1999 and 2006, there was realignment of the highway and construction of a new highway. The old highway embankment you can see in this far left photo. It was much more curvy route of the alignment. It was also constructed of a silt and clay embankment material that was locally sourced versus the new highway that went more recently was constructed and is being used today. It was mainly blast rock from quarries with a chip seal surface. There were a couple, for sure, several thermal and maintenance advantages of the old highway, but the new one was constructed to improve safety, to straighten out the alignment, and hopefully provide better performance. As you can see in the middle image, there are permafrost impacts even to the new highway that's been built. Of course, when the road transverses across bedrock, it's thaw stable material in this case, and the road embankment is very stable, but there's plenty of sections where it's extending across very ice-rich permafrost, and there's thaw settlement of the ground as a result. There's also, maintenance issues. There's culverts that unfortunately, like many roads, are impacted by settlement of the embankment over time in particular, and it's no longer providing adequate drainage. Of course, that ponded water can lead to accelerated rates of thaw and even thermal erosion underneath the embankment as well. Well, building this framework wasn't just about looking at what's there today, but it was also understanding the geologic past of that region in the context of permafrost. And part of that is understanding the terrain and its history. In this portion of the Great Slave Lowlands, it's really low relief, poorly drained ground. It was glaciated about 13,000 years before present. And then following that was a proglacial lake that occupied the region, Glacial Lake McConnell. And that's really key to understanding some of the present day superficial materials that are there, as well as the ground ice. As a result, and you can see on this map on the far right-hand side of the slide, the blue polygon is showing you the mapped, at least, extent of Glacial Lake McConnell. Here's Great Slave Lake in the middle of that map. You can see Yellowknife indicated with a red star, and then the Mackenzie River that flows as the outlet to the Great Slave Lake to the north into the Beaufort Sea. So this is just part of the geologic history, of course, of the region, but an important part. It's that lake in many areas of its extent deposited very thick sequences of silt and clay deposits that are key to understanding where the permafrost occurs today, as well as the ground ice. Right now, it's in an extensive discontinuous zone of permafrost with temperatures warmer typically than -2°C. And, based on that definition of extensive discontinuous permafrost and the field investigation that was completed, permafrost doesn't occur everywhere, right? So we need to understand the spatial distribution of permafrost and its properties and its temperature, the ground ice content, etc. Skipping ahead here to some of the findings, and keep in mind this is just a portion of this larger study, but the ice-rich permafrost is often associated with those glacial Lake McConnell sediments. It's important to have detailed superficial geology maps for that area. Also, when we look at some of the coarser grain deposits, it could be beach ridges, it could be wash till. So those are usually on the lower ice content scale, or they're ice poor materials. Another unique thing that was identified through this study were lithalsas. These are permafrost mounds formed by ice-rich permafrost that they heave up the ground. They're mineral based, so you may have heard about pulsas. These are kind of the equivalent, but instead of organic based, they're mineral based mounds. They do have very deep-seated ground ice, which is important to understanding, especially when we're designing infrastructure for that region. Approximately 1,800 of these lithalsas were mapped from historical air photos that cover the Great Slave Lowlands, and those lithalsas largely occurred within the limits of glacial Lake McConnell. So you can start to see how putting together the past information and what's there today and other data sets becomes important to identifying these features, but also understanding their spatial distribution. Unfortunately, if we look at a couple of these photos, the bottom of the screen, moving from left to right again, you can see a bleak air photo of present day of one of the lithalsas with the red arrow indicating its location. There's also these lithalsas that have ground ice. They're adjacent to the current highway embankment. The middle picture is showing you more of an elongated morphology of one of these lithalsas that, when you look at the historical air photos, actually extended across where the road embankment is now today. And then the study did not only drilled into some of this terrain and lithalsas in particular, but also completed geophysics, in particular DC resistivity surveys by the Geologic Survey of Canada. And all of this brings together and starts to build a picture of how the materials vary across space. Lastly, I wanted to bring in a little bit of the satellite INSAR work that was done by Canada Center for Remote Sensing, because it really helps with the spatial picture of ground displacement in the area and what infrastructure may be impacted. Satellite INSAR, or interferometric synthetic aperture radar, is now becoming a little bit more popular in its application in northern regions and in permafrost environments to understand ground displacement. This map that you're seeing in the center of the screen was generated over just 1 year, but it's showing displacement in different colors. And so the lakes are in black, and stable ground, or what's classified in this map as being stable ground, is in blue. Yellow is areas where the analysis of the INSAR data is suggesting 1 to 3 centimeters per year of downwards displacement, and then the orange is showing 3 to 6 centimeters of downwards displacement. This wasn't quantitatively validated, the INSAR measurements, but more in a qualitative sense. But the low to moderate areas or regions of downward displacement do agree well with some of the field investigations where we see infrastructure being impacted, and clearly there's been downwards displacement in localized areas. So I think it's, even in a qualitative sense, INSAR is really valuable. We've been using INSAR on resource development projects as well, both in the planning stage to understand terrain stability in areas that need to be considered slightly different across that piece of infrastructure that would be built, and also to monitor existing infrastructure. Just a couple more slides here showing the INSAR map. I think INSAR has a lot of application and perhaps is a piece of information that can be brought into the Permafrost Discovery Gateway. Yellowknife Airport is a good example of where there's 2 regions on the north-south and the northwest and southeast orientated runways that is showing downwards displacement, and it also aligns with some of the historic geotech investigations of the airstrip. We also have residential, right, infrastructure that has been identified as being in areas with downwards displacement. This might be houses, could be the public roads, etc., in the community. And the last piece is, to tie this together, is that some of these areas have good correlation with the superficial material. So we see sand plains, coarser grain material that is in areas where there's stable ground or there's bedrock that's stable. And then other areas that clearly are within these thalsas or within those glacial Lake McConnell sediments regions that are showing displacement. So just in summary, I wanted to highlight, the development of permafrost frameworks and their use on infrastructure projects. Like I said, it's more common in the scientific community that we develop this depth of understanding of permafrost and then use it in various ways, but it holds a lot of value for infrastructure development projects. It's taking information, it's converting it into knowledge, and then hopefully being used to inform decisions. For the example, the Great Slave Lowlands, the permafrost network or framework that was developed, keep in mind I just showed a small portion of that larger program that was led by the Geologic Survey of Canada. But it really, I think, highlights the need to understand permafrost in more depth. If that body of information and knowledge was available at the design phase of the new highway, perhaps there could have been avoidance of those lithalsas that they're now dealing with, some of the thaw settlement that's impacting the highway. There also could have been some more targeted geotech investigation to understand the areas that have ice-rich permafrost. So I think going forward, though, having a framework of permafrost for that region in particular, it is and hopefully can be used to inform decisions going forward. With that, I'll open it up for questions and turn it back over to Anna.
Fantastic. Thank you so very much, Chris.